All right, we've designed our space station, so now it's time to build our space station. One of the activities that we're going to do is we're going to simulate working in space. I've taken a piece of board and I've put some screws and nuts and a little circular screw into the board. We're going to have Jolene do a little experiment where she's going to fasten these into the wood using some tools. But to simulate a spacesuit, she's going to wear a heavy jacket and also 2 pairs of gloves. And this will simulate both the spacesuit and the space gloves that an astronaut would be wearing out in space.
Put the gloves on first and then I'll help you with the jacket. Okay.
Already hot, huh?
Oh, goody. You don't have to zip it.
Air conditioning system.
Yeah.
Well, you know it's a misnomer for astronauts to actually be walking in space. They're actually floating in space. So in order to simulate the floating in space, we're going to have Jolene kneel on this rolling chair, and we're going to see what happens as she starts to work with the tools. So Jolene, if you'll take the screwdriver, and I'll hold the board up, and if you'll screw the screw in. Okay, how about trying the nut driver? Okay, now try the pliers.
It's picking up the pliers.
Flexibility is not too good.
Very good.
You don't realize how friction and gravity affect you differently in space than it does here on Earth.
Exactly. And
Flexibility.
right, and also the fact that you're all bundled up, it limits your movement. Now we're going to try a similar activity, but this time, instead of using the screw and the bolt, we're going to use a nail. And so we've asked Rhonda to step up on the, or kneel up on the chair, and we're going to have her strike the nail, hopefully without hitting my fingers. Also, we've had to make an adjustment on the floor. We'll talk about why in just a minute, but we've had to put a piece of board on the floor and put the chair down on the piece of board. So, Rhonda, don't aim for the fingers, but hit the nail, please. Very good. If you'll notice, Rhonda turned as she was making the hits to the nail. Okay, Jenny, you want to tell us why Rhonda moved the way she did?
Okay, Jimmy. Remember Mike and doing his great demonstration with their space station? Well, imagine you're building that or working in space. What kind of scientific principles will be involved in the demonstrations you've just seen?
We're going to have no air resistance, no air friction. So any movement that we make will have, well, according to Newton's law, an equal and opposite reaction. So if I swing the hammer, it's going to push me forward, or push me back, and the hammer is going to go forward. We tried to simulate that with the chair activity, but we have too much friction on the wheels and on the board.
Well, what was going on with turning the screws, and I noticed their body rotating? Was that the same principle in action there?
I think it was. She wasn't swinging with both arms. It was just one arm, which then caused the rotation of her body.
We said we would come back to the reason the board was here. The carpeting causes a lot of friction, so in order to eliminate that friction, we put the board down to try to make the chair roll a little bit easier. It didn't work out the way we wanted it to, but it did eliminate some of the friction caused by the carpet. In a typical classroom, science classroom, you'd have tiles on the floor, and so that would eliminate a lot more of the friction, and you might get that backward motion that we were talking about. One point we need to make, you notice that as we were doing that activity, I was holding the board up and bracing myself. You wouldn't want to do that in a classroom. It could be very dangerous. So you'd want to take the board and mount it to something sturdy so that as the hammer hit the nail, the board wouldn't be moving. You wouldn't have anybody behind it.